So how many of you have understanding that how network works? Because when I started with Android development, I didn't understand what was happening when I was making a request. Okay, so how many of you really have an understanding that how network works, what is an internet, what we are communicating with? Okay, how many of you have an understanding of it? Yeah, okay. So I will consider everything that is involved from making a request to getting a response. Okay. So first I will just discuss some trivial points. For example, what is an internet? Okay. So if you see that internet, I can draw it like this. Okay. So in the internet, we have various networks. Okay. For example, this will be mobile network. Okay, this will be your home network. Okay, this will be your national or international ISPs. ISPs are internet service providers. There will be local companies, telephone companies. Okay, so there are various networks. Okay, they are all connected to each other. Okay, and the way they are connected is using routers. So this is what your internet is. Like for example, you may be in a company or at your home, you must be having your LAN, your Wi-Fi. So you are on a home network. Okay. If you are using some mobile SIMs to communicate, you are being communicating with other. You are on this network through that mobile network. Okay. ISPs are what connects everyone together. So they are national ISPs and international ISPs. Okay. So this will be the very larger suppliers of internet. Okay. So if we see this layer, okay, one layer, so it will be like there will be various systems that will be connected. Okay, for example, this is your router. Okay, and this can be your laptop. Okay, this can be your mobile and other devices. Okay, these are called end systems. Okay, also called host. Okay, so you have your laptop, your mobile, your other devices that are connected to the internet, the outer world, using a router. Okay, so now you can communicate with your friend. For example, I can communicate with Amit. He will be on a different network. That network will have other devices. So this router can be connected to this either directly or using some other ISPs. Okay, so this is your one part of the network, and you can connect with other part of the network using routers. Okay, so routers are very important in connecting one network to another. We will see how. Okay, now one thing is very important to understand here is, if suppose I am on my laptop and Amit, for example, is on other laptop. Okay, so now if I have to communicate with Amit, then what I will need to have, like any communication, we need to come at a certain protocol. Protocols are set of rules, basically the things that we agreed upon. So network has protocols. Okay, protocols is that I know that when I will be sending something to Amit, Amit will reply me back with something, so that we can communicate in this network. Okay, so I will discuss more about protocols, because protocol is what makes this network functional, and this is the most important part of the internet. Okay, so protocol, first thing is the format of the message. Okay, when we send something on a network, what we are essentially doing is we are sending some bits of information. Okay, it is like electrical pulse. We are sending zeros and one across this network. Okay, so I send a set of bits from my laptop to the Amit's laptop, and we have designed this bit, okay, to form some standard format, okay, that comes under the protocol. So protocol defines exactly what will be the format of messages. Okay, it will define the order of message exchange. Okay, and it will also define the actions on transmission and reception. Okay, so this protocol defines that the message that I am sending, what is the structure of that message. Okay, and it defines the sequence of message exchange. For example, if I am sending message, then he will not be sending message, he will wait for a reception. Now when he receives it, he will send me some acknowledgement. So there is an order of message exchange, and suppose I receive a message, then I will send a response. So set of actions that are must be done when something happens on the internet is also defined. So these definitions make a communication possible on the internet, and they are called protocols. Okay, so there are two protocols that are most important that makes our network what we experience. So one is TCP and another is IP. TCP is transmission control protocol and IP is the internet protocol. So basically what they do is they defines the process that a message will go through so that it can be delivered from one place to another. Okay, and these TCP IP protocols are actually maintained by IETF, Internet Engineering Task Force. This is an organization that has developed the TCP IP protocols, and they have done this using RFCs, request for comments. So when internet was coming up, everybody was contributing that what should be the format of message, what will happen when something is received. So these RFCs, they are documents that get converted into protocol, and this organization is responsible for maintaining this protocol. Okay, so till now we have understood that internet works because of these protocols. Okay, and this is very important for us also to understand that when we send a request to a server, we need to understand that everything that is happening under the hood of OKHTTP or HTTP URL connection, they are all designed to go through this protocol. Okay, now we will come to this end system, okay, and see that why this protocol is important. Okay, Now suppose this is me, okay, and this is Amit. Okay, now I need to send some information to Amit. What I can do, I can first write a letter and send it out from the window. Will it reach to Amit if I just write something on a piece of paper and send it out of the window? It will not reach Amit. Okay, so in order for this message to get delivered to Amit, there is a concept that is very important, which is API. Okay, API is application programming interface. Okay, API are basically the set of defined things. Okay, that will take place when we want something to be done. For example, if we have a radio, okay, radio device, we can move the knob that will connect to different frequency. So that knob is actually providing an API. So API are simple constructs that help us communicate with a service. Okay, so in order for us to communicate, there will be a postal service. We'll call it postal service API. Okay, what is this postal service API? It provides certain principles, certain rules which I need to follow in order for something to happen. So that is an API. API says that if you want to achieve something, you need to do things in a certain way. Okay, now this postal service API requires me to first pack my letter in an envelope. Okay, write the name of the receiver in the center and add a stamp here on the top right. And after doing this, he must put this in authorized deposit centers for this envelope, and now this postal service will be able to pick this up and get it delivered. So now we understand that in order to achieve this process of sending message from one person to another, it must follow some API. Okay, and this API is what provides it by the TCP IP. Okay, now here we are two people, okay, and this is the end system. So there are two set of programs that works on an internet, okay, for the end system to communicate, and that is called as client server program.
One thing we need to understand again, the TCP and the IP little bit more deeply.
Okay, so TCP and IP are basically protocols. Okay, they define that how the message will be sent from one host to another host. Okay, it defines the format of the messages. We will see further in the lecture what that is. For example, format of message should be such that it should have some header. Header will have certain things that need to be defined. Okay, and when that packet is moved on the internet, this router works in a certain way, and how this router works is also defined by the TCP IP. We will further see in this lecture. Okay, so now we have client server program. So any host can be a client and any host can be a server. Okay, so basically we have a client program and a server program. Okay, so client request for some service from the server, and then server can reply back with that resource that client wants. Okay, so this client program is like our web browsers. Okay, our, for example, OKHTTP client. Okay, and these server programs are like Nginx, it is like Node.js or Tomcat. Okay, so client programs request for some resource from a server program, and the server program will return with that resource on validating the request. So in the internet, somebody works as a client and somebody works as a server, but there is also one hybrid structure that is called peer-to-peer networking. Okay, peer-to-peer program. So till now we saw that I can work as a client or as a server. Okay, but sometimes one program can work as both, as a client and as a server. Okay, so those programs which act as both as a client and server are called P2P programs. And example of this is BitTorrent. Okay, so when I need to get some file from somebody else, I can ask for it. So I'm a client there and somebody is providing that file, he is a server. Now somebody can ask me that provide me a file, that time I will act as a server. So a program can work as both client and server are called P2P programs. Okay. Now till now what we have understood is internet is a connection of various smaller networks. Okay, in order to communicate over the network we need to agree on certain rules, certain protocols. We call that protocol, okay, as a combination of those protocols, important protocols, are TCP IP. After that there is a layer above that protocol, that is somebody act as a client and somebody act as a server, and there is something in between, that is P2P programs. So till now we have understood how things are working on the internet, but if for example I want to talk to Amit, how will this network know that my message should be delivered to where? Okay, for example in our postal example, service example, postal service API required me to write the address. So using that address and pin code, it was able to find the person to whom we should deliver. In the internet, this is equivalent to IP address. Okay. Okay, so we have IP address. So all the devices that are on this network must have a unique IP address. Okay, for example, this, suppose this was an end system, this was one computer, this must have IP address something, and this computer must have IP address something, and they must be unique. If IP address collides, both the system is turned off the network until they resolve the duplicate IP addresses. Okay, so if you see the IP address, it will be something like this. You must have identified this. This is the IP address of your local host. Okay, so this IP address has 4 parts. So some part of this IP address will be there are two parts to this. One is network ID and there is your host ID or the client ID. So this number has two information about your network and about your client. In order to identify which part of this is identified as network, there is something called subnet mask. Okay, this subnet mask will be something like this. Okay, if it is like this, what does it mean? It means that the 255 number indicates your network ID and 0 number indicate your client ID. Okay, so if this is your IP address and this is a subnet mask on it, this 255, this part is 255, so this will be part of network. This part is 255, this will be also part of network, similarly this, and this will be part of your client ID. So now you can, using this subnet mask, you can extract this network ID, which will be 196.0 and client ID is 1. Okay, so every IP address has network ID and client ID. You can find what is your network ID using subnet mask. Okay, now let's understand the role of this IP address. Okay, suppose this is my Wi-Fi and I am connected to this Wi-Fi here, and suppose Amit came to my house, he is also on the same Wi-Fi, we are on the same network. Okay, how we are on the same network? For example, my IP address is 196.168.0.2, Amit has 196.168.0.3, and subnet mask for this router is 255.255.255.0. Now this identifies the network, so this will be your network ID and this will be your network ID. So our both network IDs are same, so we are on the same network. Okay, and our client IDs are different. Now if I want to send some message from here to here, it will be directly transferred to Amit. Okay, so there will be no issue here because we are on the same network. When I send this information, I have the information of all the IP address in my network. I can directly send here. Okay, but now let's assume that Amit is at his house. Okay, he is connected to some other network, some other router. Okay, now Amit is here. If I want to send now message to Amit, okay, Amit has, for example, IP address here 196.168.0.3. Okay, subnet mask is again 255.255.255.0. So this is the network ID, this is my network ID. Both are same, but we are on different networks, so I don't have any information about this network. Okay, so what we can do, we can connect our routers. Okay, now when I connect these routers, this router helps to send this information from me to Amit. Okay, how does it do? So if you will see, this is very interesting part. Suppose this is a router. Okay, suppose this is a router. Each router must have minimum of 2 INCs. Okay, NICs, network interface. Okay, so this NIC is a network interface, so each router must have 2 NICs, basically meaning that each router must have two outlets. Okay, one will connect to one's network and other will connect to another network. Okay, it can have multiple NICs as well to connect more than two networks. Okay, so suppose this is the network, this is my network, and this was Amit's network. Okay, I'm here, Amit is here. Now I have to send this to Amit. Okay, so I'll send the message. I don't know about the address of Amit. Okay, this network does not have the address of Amit, so I'll send this message to the default port. Okay, I'll send this message to the default port, and default port is the port of the default IP address points to the router. So I will send this to the default IP address, which will go to this router. This router, on receiving the message on the default port, will then forward it to the next network. So it will forward it here, and this now have the information of Amit, so it will reach there. Okay, so whenever an IP address is not in the network, it is forwarded on the default port. Okay, and default port is the port of the router. Okay, this is called default gateway. So if suppose I need to send information here and there are more than one routers, for example we are connected to different network services. Okay, so for example I have my network service, he has his network service, and both are connected through the national ISPs. Okay, so I will send the package to default gateway because his IP address, for example, is 10.1.0.1. My IP address is 11.0.1.0.1. Okay, let's assume. So I have to send this message to 10.1.0.1. Now this does not exist on my network. So I will forward this to default gateway. Now this router will try to find the IP address in the next network. So now it does not know about this IP address in the next network. So it will forward in its own default gateway. So this default gateway is connected to the next router's default gateway. So the packet will come here, and this packet will not have this IP address in its network, so it will then forward to its default address, the default gateway. Now this, on receiving the message on the default gateway, it can now find this address in the network, so it will be able to send this message. So this path that the packet takes is called the route, and this is how a message is able to delivered from you to any of your friend, and the routers help in switching the packets from one network to another network by using the default gateway. Okay, so now we have understood that IP address helps in sending message on the internet, and routers play a part in finding out that address for us. Okay, now in order to understand internet, so I can say that internet is a layered structure. What do I mean by layered? Okay, so the structure of internet is like this. Okay, the top layer, the bottommost layer is called network interface. Okay, what is the network interface? It is the Ethernet. Okay, and above that we have IP. Okay, So this is the network layer. Okay, first we have a connection, then we have an IP address, and then we have the transport layer. Transport layer is our TCP or UDP. They are protocols that define that how messages will be handled in the network, and above that we have application layer. Okay, so application layer are like HTTP. Okay, so their application layer, they actually define that how one application will be able to process the message and how it will be able to send. So this is our internet. We have a network interface through which we connect. We are identified in the network with the IP address. In order to send information, there is a transport layer, we call it TCP. Okay, and above that the application layer, we are shielded by all of these. When we write our programs, this layer is what we interact with. Okay, so this is how the internet is structured. Okay, now till now, how many of you got the idea that how the internet is working for us in order to send the information? Okay, did you get some idea that how the network works? Can you reply?
Everyone got the idea.
Yeah, so very nice. Okay, give me a sec. Okay, fine. So till now we have understood how internet is working. Now we will see when we are sending a message how it is going through the network. Okay, so when we suppose I have, this is me again, this is Amit again. Okay, now I need to send a message to Amit. Okay, so if I write a message, that message will be sent not in one chunk. What will happen is that the message of mine will be broken into various parts. Okay, this part is called packet. Okay, and what packet has is the information about where it is going and what information it carries. So there is a header on each packet, and the format of header is defined by HTTPS. Okay, and TCP IP. Okay, HTTPS is an application layer over TCP IP. So this packet, each packet, I broke down my message into various packets. Each packet I define a header. I write in each file, each packet, some bits. That is the information about this packet. And now my all the packets move independently on this network. Okay, suppose this packet goes through this, one packet goes through these routers, another packet can go through this router. Okay, so independently all the packets are moved on the network, and finally when Amit receives all the packets, he will not receive in the order, he will receive in the jumbled order, but all the packets have header which defines the sequence. So Amit will be able to construct the message again, okay, based on the packets he receives. Okay, now if suppose some packet was that Amit received was tampered, it was not the incorrect format, so Amit can ask again to me that send the packet again, so I will just send that packet. Okay, this is how any message moves on the internet. Okay, After understanding how packets move, now we will see about HTTP. Okay. HTTP. Okay. So what's the full form of HTTP? Can you write?
Hypertext transfer protocol, everyone writing.
Yeah. So now my next question will be, okay. So there are three things here: hypertext, transfer, and protocol. Okay. Hypertext was originally meant that if I have a document, I can have something in that document which links to some other resource on the internet. Okay. So hypertext will have links to some other network. Okay. And then this transfer protocol. Transfer means how my text will move from one client, one host to another host. Okay. So now you are sending JSON data in your Android application, or if you have web application, you are sending using AJAX call. Okay. So that is not, is it a hypertext? The JSON that you are sending, is it a hypertext?
It's 50-50, yes and no.
Okay, so that is not an hypertext, okay, because that does not have any link to another web resource. So this was originally, when historically designed, that was designed for web pages, but now this has extended to support all kinds of documents now. Okay, now HTTP protocol is version 1.1, and now 2 has also been released. So in the next version, we have all kinds of documents that can be sent from using this protocol. Okay. Now we can send images, we can send plain or like JSON objects, we can send like web pages, CSS files, and everything using this protocol. Okay. And this HTTP comes in the application layer. The diagram that we drew, where we have application layer on top, okay, above the transmission protocol. So HTTP is an application layer, okay, and it follows the client server protocol. Okay. So when we are making a request, HTTP is stateless. It means that when you connect to a server, okay, you make a connection. How to make a connection is defined by HTTP. We will discuss just now after this. And then when we are sending one request, and then after that we are sending the another request, both the request will have no context using on as design of HTTP. This is called stateless. Stateless means that one subsequent request, each new request don't have any idea of other request, but there can be some context using cookies. Okay. And also HTTP defines certain things for us, certain methods, for example get request, okay, post request, and other request. Okay. And it also defines the response codes. Okay. These response codes help to identify what the server is communicating to us, and we can communicate with our server for certain things based on the various methods. Okay. Now when we make a request, okay, for example, I'm the client or the host, okay, I want to communicate to a server, okay, which is another host. Now when I send some messages, so in between the messages are intercepted by other layers, so these are called proxy servers, okay, so they act as a proxy. When I send some information, they will capture that request, it can forward to other proxies, and then finally it will receive on the server, similarly back and forth. Okay, so what is the role of this proxy? Okay, this act as a gateway to define where to send the information, or it can cache the request. Okay, so the basic uses will be caching, okay, then it will be used for filtering. For example, if you want that some spam messages would be filtered, this proxy will do that for us. And then it will be for load balancing if you are from the server side. Load balancing means that if you have 5 servers and if you make a request, okay, the large amount of request coming on, so this proxy servers will act as a load balancer to route that request to the server which can process it. Okay, it can be for authentication, okay, or it can be also for logging, where requests are coming and what response are being given. So between a client and host, we must understand that we do not talk directly to a server. There can be other layers that will come in between that act as proxy layers. This can be dangerous if we don't control it. We will see what problems we can have because of these proxy servers. Okay, one thing I would like to mention that HTTP 1 and 2. Okay, now we have HTTP 2 and earlier we have HTTP 1. So initially they provided human readable data message format. Okay, HTTP 1 provided human readable data format that we can directly read what are in the header bytes, what is in the body. HTTP 2 wraps it, okay, wraps the request in a frame, and that is not readable by humans. Okay, the frames help us to compress the packets more compared to HTTP. Also, in newer version we can use a single connection to make multiple requests. Okay, but this is hard to implement, so we are not using that part, but we are using a single request in one connection. Okay, and HTTP follows the TCP IP standards. Whatever TCP IP has said that what should be the format of messages, how it should move, TCP IP follows that. HTTP follows that. Okay, now till now we have understood that what is HTTP, okay, how it is helping us in making the message move from one place to another. Okay, what are the systems that come into play when we make the call. Okay, now how many of you know that how the HTTP handshake works? Basically, when you ask a server for a resource, what is happening, that how I am able to connect. How many of you knows this thing? Can you reply?
no idea about that.
Yeah, so this is a very important thing that I want to really consider, that we are making HTTP requests in our application. Okay, if we don't understand what's happening, so we won't be able to really understand the security aspect of our application. Okay, so we have two things, HTTP and HTTPS. Okay, now everybody is using HTTPS. How many of you know the difference between HTTP and HTTPS? Yeah,
Most of them, they are telling it's more secure.
yeah, so we know that HTTPS is an S over HTTP, that is secure. Okay, but how it is secure, let's see. Okay, so suppose this is me. Okay, and this is Amit. Okay, or let's say this is my server. Okay, this is my dog server. Okay, and this is my your Instagram app, for example. Okay, this is your app. Now in HTTP, what will happen is I will first send something to the server. This is called sync bits. Okay, these are bits. Okay, zeros and one information. I will send it to the server. Server, on receiving that sync bit, it will reply by acknowledgement that it has received that bit. Okay, and it will also send another sync bit. Okay, and finally app will receive the acknowledgement and sync bit, and then it will again reply with the acknowledgement. Okay, so in normal words I can say that, suppose this is me, this is Amit. I will say that hey, I want to talk to you. Okay, this is my identification, this is my name. So Amit will receive my name, he will understand, he will know that okay, this is me, and then the server will send an acknowledgement, yes, I know you, but he's not sure that he's Amit. So he will say that yes, I am Amit, do you know me? So application will say that yes, I will say that yes, I know you. So now both know each other. So now after this handshake, this is called three-way handshake. After this handshake, we both can freely send messages. Okay, this is the HTTP handshake. Okay, now let's understand something here. Okay, why this was unsecure, why it is dangerous. Suppose between this app and server, between this app and server, some proxy layer comes, somebody comes, this is called man in middle. Okay, now app will send an information to this server. Okay, this is an imposter, it will say yes, I know you, and it will then send that information to the server. Okay, server will return a response, it will forward this response to this. Okay, now since it is HTTP, all the messages sent by app and server can be read by anybody, which it is human readable. So this man in middle will be able to read what app is sending and what is server sending it back. So this will be able to capture everything, for example our credit card, okay, any crucial passwords like, and it can use those credit card number and passwords to do something very bad. So that's why HTTP is not secure. Okay, so now everybody has moved to HTTPS. If you are still using HTTP, meanings if your URL is like this, okay, if your URL is like this, you should definitely consider moving away from it. Okay, HTTP is not secure, anybody can intercept and read those messages. Okay, so how did HTTPS helps in securing it? Okay, let's understand. So how many of you really identified the problem that I just explained and think that HTTP is really dangerous for use?
Yes, everyone.
Yeah, so HTTP, we have come with a better protocol for HTTPS. Okay, let's see what it is. Okay, now HTTPS is, we can write, let's just remove HTTP from on my board. Yeah, so now I have HTTP secure. Okay, that is HTTPS. Okay, so what HTTPS uses, it uses another protocol, SSL or TLS. Okay, SSL full form is secure socket layer. Okay, and your TLS is transport layer security. So SSL was used before HTTP in order to send something in the encrypted format, and now with HTTPS it uses the same principle and development over SSL, that is transport layer security. What essentially it is, I'll explain now. Okay, just to mention that latest version is 3, SSL 3, and it is version 1 and 1.2. okay, 1.1 and 1.2. okay, so HTTPS works in a different protocol, SSL or TLS protocol. Okay, this is an advancement over SSL for the HTTPS. Okay, this latest version SSL 3 and its secure version is 1.1 and 1.2. Now let's understand SSL and TLS handshake. Okay, we saw how HTTP helps to communicate by handshaking in 3 ways, but that was susceptible to interception. Let's see how this helps to secure that handshake. Okay, in this process what happens is, so this is your client. Okay, this is your app and this is your server. Okay, so when this client want to communicate with this server, it will first say hello. Okay, hello. Okay, in this hello, what it will do, first thing it will do is it will send all the list of SSL versions that it support and TLS version it support. It says that I have these versions available with me, okay, to the server. And also it says that I have these cryptographic algorithms. Okay, it can say that I have, for example, AES algorithm with me, okay, RSA algorithm with me, okay. It will send the list of algorithms that it has and also the versions of SSL and TLS it has. Further, it will send data compression mechanism. How it is compressing the data. So when it wants to communicate, it sends these three things to the server. Okay. Now the server replies back and it says hello. In this connection, what server says is that yes, it has taken one SSL, agrees upon one SSL version, okay, and cryptographic algorithm from the list that client has provided. Server says yes, let's use one of the algorithm. So it agrees on algorithm and SSL suit, that is which version we should use, okay. And it also sends the certificate, okay, the SSL certificate. Okay, so this is a very important part, SSL certificate. Okay, this SSL certificate is a certificate that this server has issued itself from some providers. Okay, so there are some CAs, certificate authority, which provides this certificate. So server has taken the certificate from that CAs and that provide back to the client that SSL certificate. It has the public key of encryption algorithm and it also has the fingerprint. Okay, now this client receives the certificate. Now it goes to the CAs. Okay, our web browser has already a list of CAs installed with it. We can install manually also. CAs like GoDaddy, Let's Encrypt. Okay, so I have these CAs. Okay, I will send the certificate to the CAs and that CAs will verify the fingerprint. Okay, and reply back to the client that yes, I have issued this certificate and this is valid. So we are relying on these CAs that the server says who is. Okay, now this certificate has the public key. The public key was sent by the server to the client. Now what happens is that client sends an information, okay, to the server. It is a key, okay, which is called a shared key. So before I mention that, in the encryption what happens, there is two keys, private and public. Okay, so when I send some data, I can encrypt with public key. but can only be decrypted by using private key. So that is the way encryption works, okay, using private key and public key for asymmetric hashing, asymmetric cryptographic algorithms. Okay, so now the client receives the public key from the server. Okay, a private key is maintained at the server itself, it is secure. Now client generates a key. Okay, it generates a key, encrypt that key using the public key based on the algorithm. Okay, based on the algorithm it will encrypt this by using the public key. Okay, and then it will encrypt its message using that shared key. Okay, now this message is encrypted, this key is encrypted with the public key of the server, and it will send that information back to the server. Okay, now server will receive this and it will first use its private key to decrypt this shared key. Okay, use this private key to get the shared key. Okay, and using this shared key now it can decrypt this message. So now server has a key which is maintained at the client. It is sent securely over the network using the encryption using public key. Nobody could read this key because it can only be decrypted with private key which server has. Okay, and it encrypt this message with the shared key based on the algorithm agreed upon. So now this message is encrypted, this key is encrypted, nobody even in between comes and read the message, it won't be able to make sense of it. That's how it has made secure. Now the server will receive this and get the key out of it using the private key and can read the message. Okay, similar, after that the server will provide a message. Okay, that message will be encrypted using this shared key. This means that client says, look, I have this key here that is encrypted based on your key, and this is message which is encrypted by my key. Can you read it and can you make sense of it? Server makes sense of it, sends a message, look, this is my message, I have used your key to encrypt it, can you read it? After this reads, they can share messages securely. Okay, so this is how HTTPS makes our request secure. So how many of you really found it fascinating that how HTTPS is helping to send our data securely, and this is really something phenomenal which I have achieved.
Everyone got how it works HTTPS.
Yeah, so when we send something, some message using HTTP, there is a format. Let's understand that. Okay, when we make an HTTP request, okay, there is something like this. You have header will have this written. Okay, and other headers. So basically when we are sending information or request, it will have a method in the header, a path in the header, and the HTTP version that I am using for this package, okay, and other headers. Similarly, when server returns a response, it will write in the header, it it will write about the versions that it is using, okay, and the status code and the status message, and in the header it will have other things like date, server and other headers. Okay, so this, when you make a request, each message goes with this header, and when we receive a message, each response has this header. Okay, now there is one concept we call RESTful APIs, the REST APIs. Okay, RESTful APIs means this is an architectural design pattern which is implied, and there are some principles for that. Basically, for understanding it, it means that your system should be stateless and it should communicate with particular methods like get, post, put, delete. Okay, so what each method does will have a same throughout the application. So get will be used to fetch something, some resource, without manipulating the data. Post, generally this depends on how the architecture at the server interprets that. Post can be used to put anything new into the field, into the server or database. Put can be used to update it, okay, and delete to remove it. When you want certain thing to be done at the server, you need to specify a method, and that comes under the RESTful architecture. Okay, now this was all about the network from the perspective of the software developer. Now we will come back to our Android. Okay, we saw all these things. Okay, so now the network layer that we will be using is retrofit. Okay, so how many of you have worked with retrofit? Can you reply? How many of you work with retrofit? Okay, so how many of you have worked with retrofit? So basically,
So we have like yes and no 50-50.
yeah, so retrofit is basically architecture above the OK HTTP. Okay, it internally uses OK HTTP to make any request. In Java, we have like these services. Okay, we have HTTP URL connection and HTTPS URL connection. These two constructs were earlier used to make any request. Now we have retrofit. OK HTTP handles everything for us. For example, if we need to send something, it divides into packages, it marks the headers for us, so it does everything for us if we need to send some information. Okay, and here I would like to mention that retrofit is a REST client that is based on the RESTful principles that we just discussed. Okay, so basically if I would put here that I'll put a diagram here. Okay, in the retrofit, okay, there is base URL. Okay, we need to specify a base URL, then we need to specify a client. Okay, so what client it should use? You have to provide your own instance of a client of OK HTTP. Okay, and this OK HTTP client will have certain properties. Okay, what we have used in our architecture, there is a cache. Okay, then there is header interceptor, then there is refresh token interceptor, okay, then we have HTTP login interceptor, okay, and then we have timeouts, that after what time I will consider the request to be cancelled if we don't get a response back from the server. And this retrofit then takes converter, okay, a converter factory. The role of this converter factory is that we are sending information using OK HTTP. Okay, when we send the information, we want a POJO to be passed. For example, in the example, you will see a dummy request. Okay, so you passed dummy request to the retrofit, and in the response, you get the dummy response. Okay, it means that you are getting the POJO. So this converter factory helps in converting the string request that you get from the OK HTTP, okay, from converting into back into the body and getting from body the object. Okay, so this converter factory we provide the JSON converter factory. Okay, and pass a new instance of our JSON. Okay, and then we have call adapter factory. So basically retrofit do not provide Rx Java observables by default. Okay, it provides a call object, but we want to use it with Rx Java. So in order to do that, we will provide a call adapter factory, and that will be Rx Java 2 to call factory. Okay, adapter factory. So in the call adapter factory, I'll tell the retrofit whatever response you are getting, provide it into the Rx Java observables. Okay, and then when we create, we need to pass something here. Let's see what is that. So this, when if you will see in our network service networking module that is in the base project, you will see this code in the networking, which has a create method. It gets one instance of this retrofit, and this is maintained as a singleton. Why it is a singleton? Because this is a very expensive resource. We want to reuse it for making multiple requests. So at the application level, a single instance is maintained. So the networking, the class networking has a method that returns this, okay, static method. Now retrofit has one this instance, this is retrofit service. Okay, now what I will have to define is the APIs in retrofit. Okay, so now for retrofit to know that what all APIs are there and what I have to do to make the request, we have an API interface for that. Okay, I have named in our project the network service. Okay, this network service interface defines certain methods. Okay, let's see. For example, I have a function. Okay, function I have named anything like do dummy call. Okay, and in that method I have written @body. and variable name request, and type is a dummy request, and it returns a dummy response, a single of dummy response. Okay, and I have marked few things here. First thing is the URL, okay, the method. This is a post method and the URL. For example, I have called it dummy. Okay, and there is a header. Okay, call it public. Basically, what we have done is we have defined how our API works. We have written everything in the interface. Okay, we have written that when I call dummy, do dummy call and pass in the dummy request instance, you put it in the body by serializing it using this JSON factory. Okay, and then when you are making the request, use the header which I have attached here and make it a post request to this URL, and when we created, we have added base URL. So when I mention this URL will be basically base URL / this dummy, whatever the value of base URL. So it will make a post request at that URL, and it will give a response in a single, okay, in RxJava, and that will provide the result as a dummy response. It will deserialize the response string into this POJO. Okay, so this is how we define our APIs. So there are few things here. Suppose this dummy is configurable. For example, dummy and something like we want to name it ID. For example, we want that the ID which I provide into this function should go into this URL. So this is a way to specify the dynamic URL, that you place a bracket, put the field name, and in the method you have to add this @path, okay, and pass this ID, same name that you have used here, you have to write here, okay, and the name, for example ID, and type string. So when you call this do dummy call, pass this ID from outside, it will go into the path, replace this ID field with the string you have provided. So this you can use to dynamically create this URL. Okay, so now you have understand the method, the dynamic URL, putting headers. Okay, this will be a key value pair like this, something name. Okay, so this will be the key, this will be the value for the header, and in the body what you want, and in the response what you want. There is one more thing, add query parameters. Suppose you want to add something like here in the URL, you want to add dummy base URL and something like this, a is equals to 2, okay, in the URL. Then for doing that, you have one more annotation, @query, and whatever name you want to supply you will write here, and the value you will pass from outside. So whatever you pass, this will be formed here. So that's a way to write the query parameter using the in the retrofit. So this is the format that you will see in our project as network service, and you need to define every API there. Okay, and finally when you receive this, you can do your process. Okay, so in the create method here, you need to specify this class name. So now retrofit will be able to use all this configuration, and this it will create an instance of this class and implement these methods for you. You don't have to do it for yourself, and then it will return a retrofit service that you need to maintain to make the API call you have mentioned here. Okay, So how many of you understood how retrofit is designed to make a request?
Everyone got.
Yeah. So now there is very important thing which is called interceptors. Okay. So we will see and understand how interceptor works. And there is one more thing which I would like to emphasize before we go to interceptors. Okay, so now you must have seen in our project that I have used a construct where I have written @header in the networking service. I have written something like a key and value. For example, it's like, if you go into the definition, it will be like auth type, okay, something like this, and its name is public or protected, and it can be public at some of the APIs. So what I have tried to do for a better design is that since we need to like write headers on each request, okay, in each function I have to write it. So if I do that, that will be very difficult because I need to pass that, okay, or somewhere I have to maintain that, so that if I write that function, I will add, for example, you need to add API key, okay, in each request, public request, you need to add this. This header need to be attached everywhere, so you need to write this on every function. Similarly, for all those APIs, so there are two type of APIs, public and protected. Public API is for everyone who has this API key, for example, login, sign up, okay, but some APIs are protected. For example, only the logged in user can access those APIs. For example, create post, get post list, these are protected APIs, okay. So for all the protected APIs, you need to add these headers, okay, access token and user ID, in addition to API key. You need to add these on every API request that you make for protected APIs. Okay, so in order to, you will receive these tokens when you log in. When you log in or sign up, you will receive these tokens, this information, this token and the user ID. Okay, so you need to mention that information, that keys everywhere. So if you go and write on every function, that will be very difficult to do. So what I have done, I have created interceptor, and that is how powerful interceptors are. So what I have done, I have just marked each APIs that either it is protected or public. I have added a manual header on each API, just one line, that what is it of type, is it public or it is protected. Okay, now let me tell you something about the interceptors. Okay, before that I will tell you something more about this. Okay, so when you log in or sign up, you receive three things. API key you have when you build your application, it is supplied by us to you. Okay, now when you log in or sign up, you receive three things, in fact four things. One is user ID, another is access token, and refresh token, and other user information like username, etc. Okay, so these access token and refresh token are important. Okay, we have everything encrypted using HTTPS, so that's a secure part, but we also want to identify that who is asking for this resource. is that guy is somebody who we have authenticated. So for that there is access token and refresh token. Access token has information about the expiry. It has encoded information in it. Okay, we are using JWT token. So this has encoded information that for whom, what is the client, and what is the purpose. Okay, expiry date. So access token can expire in certain days. For example, let's say we have 30 days. And refresh token also has this information plus for which token it is supplied. So it may be valid for 90 days. Okay. So why two tokens? Okay. This access token is required to make any request which required user identity. Okay. But after 30 days, this access token will be expired. So we cannot use this token to call any APIs. This is for the security perspective, that if you leave your phone for some time and then somebody try to use, he won't be able to. He will have to log in again. But that will be a painful if you have to log in again, if you cannot log out after 30 days. Okay, because that person may be using that same device. So there is refresh token. So refresh token has a longer validity, much longer validity than the access token. When your token expires, you will silently use this refresh token. You will send this refresh token to an API to refresh it. Okay, and then you will receive a new refresh token and the new access token. Okay, so when token expires, you need to call this within 90 days using refresh token, that I need to refresh this token, and then you will get a new refresh token, a new access token. Its validity will be enhanced. But even after 90 days you do not log in, then you will be forced logged out and you will have to log in again. So that is the role of access token and refresh token. Okay, now since we have understood this credential part, let's come back what I have done for the headers. Okay, so there is an interceptor. You will see in the network package, in the remote package, if you'll go, you will see that you have package interceptor, and there you can see request interceptor. Okay, so what is an interceptor? In OK HTTP, okay, in the OK HTTP, suppose I have a request and finally making a call, I will have a response, and in between I can supply as much interceptor as I want. What interceptor does, it before making a request, it can capture that request, make some modification or do whatever it wants with the request. Okay, and after making modification, it will call again. Similarly, it can also capture the response, make some thing with the response, some modification it can do, and then forward it to the application. So these are the rules of interceptors. So you will see that I have written one API header. Okay, this API header has fetchers, okay, which has user ID fetcher, request access token fetcher, and the refresh token fetcher. So basically these are functions which when I invoke, these are provided in the application DI package. So where what I have written is, when these are called, I will go into shared preferences and then I will be able to read from the shared preference the current value. Okay, so when I call this .fetch method, it actually reads from the shared preference what is the current value stored and provide it back. Okay, so in the request interception, first thing what I did was, in every request I extracted this header which I have supplied with the key auth header key. Okay, the name which I have written you can see there. So the key which I have specified, what is it is protected or private. I extract that information, and based on that information what I will do, I will here call these methods. If it is public, I will call the API key. API key won't change, so I don't need a fetcher. I will call API key and manually add into the header. If it is protected, I will call fetcher of this and this. This will get the current value from the shared preference and add the header to that request. So now I don't have to write when I define the function. I could manually inject those headers by putting a request header interceptor. Okay, this is header interceptor. Okay, so how many of you did get to till here?
Last part again.
Okay.
Like this 50-50.
Okay. So you will see that in the code that each API is okay. Function make do dummy call, for example, there is a tag header. Okay, and this header has auth key. Okay, and this is, for example, protected. This header I have supplied. So in the header before colon, this becomes the key and this is the value in that goes into the header. In the request interceptor, whenever this call is made, first a request object will be supplied to this request interceptor. Okay, so I have interceptor here, header interceptor. Okay, I'll get a request. This request will have this header. Okay, I will read this request for this key. Okay, and this will provide the string protected. If I see protected in this request, what I will do, the header I have which has these functions. So in the request I will supply the new header which is X API key, and value I will provide dot add. Okay, I'll provide the API key which the header has. Okay, similarly, since it is protected, I need to also add access X access token. Okay, and I will add by calling this token fetcher in the API header, that is fetch. Okay, similarly for the user ID, call the fetch of this method. So basically what I have done, I have intercepted the request, identified that what header I need to attach to this, and then added the header to that in the interceptor. Okay, now there is one other interceptor which is called refresh token interceptor, that is more complicated. So what I will do is, I will not take that right now. Okay, I will describe it in some other class what refresh token interceptor is. Okay, how it works I will define it some other class or video. So basically, just to give an idea, that suppose you have a request, you made a request, okay, but this request failed because access token expired. So now this access token is expired. This interceptor will intercept the response, okay, and read the header that this has 401, and the instruction is that I need to refresh in the header. Okay, so when this happens, I make another API call in synchronized fashion. In the same thread, I will make another API call to refresh it, and this will come back with the new access token and refresh token, new refresh token. I will save them, and then that request, I will again make that request by changing the header with the new token that is received. Okay, so this is what refresh token is doing. This is a little complicated in design. I'll consider it in some other lecture. Okay, this has one problem, that suppose you have multiple requests, you just want to make one refresh token request and wait all till new token is arrived, and then re-request all those API calls. Okay, so till now we understood that what we have done in our application. Okay, so one thing is, this is not very valid for us, but for a conceptual point, just I want to mention that there is a concept called offline first. App. What it means is that if suppose you don't have a network, you will still have some information to use to show to the user. Okay, so there are various design pattern that you can follow. There are two pattern that is important. One is DB first and network caching. Okay, as you know that we have fast Android networking. Amit has created this library, and this is one of the highest rated library on GitHub for Android, and the companies with millions of downloads are using it. So Amit has huge expertise on this. Okay, so network caching is basically that we provided was a disk cache. Okay, more information Amit will provide, okay, in the coming lectures. So now DB first approach means that you make the source of truth as the DB. How can that design be in a simplest format? If I draw, then it will be like this. Whenever this is your UI, it needs data, so it will ask with a repository. We have the same repository layer in our app, okay, in our base. So this will ask with the DB. Everything is going into the DB. It will ask with the DB, and if DB's data is stale, it will still forward to the UI, but at the same time make a network request. Network request with the most latest data. Now after this response, it will save the latest data into the DB. So always you are getting data from the DB, and it becomes stale, network is updating the DB. So this is your source of truth. Okay, so if you create this architecture, you will always have some data to show to the user. So this comes into the category of offline first app. Okay, network caching is basically that every response you get have certain properties to it. Okay, so there are properties like e tags. Okay, their property like cache control, header. Okay, so when you get a response, you will get this cache control if the API has designed for it. It means that if this cache control is 30 days, it is saying to the client that within 30 days don't ask for new data, use the data that I have provided. So this cache control header, if it has, what I will do, I will save that data into a disk cache. Okay, HTTP does that by default. You will see into the builder that I have sent a cache file, the app cache file, and the size of the cache. So it will keep that response and the request mapping into the disk cache. And whenever I make that API request again, within 30 days it will provide me the same information. Okay, after 30 days, okay, when I make the request, I will send the e tag. If e tag is basically a hash key, okay, of the file, the information that I got, there is a hash key unique identifier for that response. So when I send the response with and I request, I have that e tags there. So server will request response based on the e tag. It will server will check that the e tag that you have supplied is it same that it has, means data has changed or not. If it has not changed, it will send 301. So then also you will use the same data that is in your disk cache. So that is also one way to design the offline first app. More information Amit will tell you in the coming lectures for the caching. Okay, so we have covered a lot of things. So how many of you got what I wanted to explain? Okay,
Yes, everyone got it.
yeah, nice. So like I will take 5 more minutes. Okay, one thing that I want to mention is port. Okay, DNS and port. For example, when you write mindocs.com, okay, https, okay, when you write this, how we are able to connect to my server? Okay, so there are certain things here. This is the protocol through which you need to communicate. This is your domain name. Okay, and for HTTPS by default it is port 443, and if it is HTTP it will be port 80. Okay, so what is this port? So first thing, when you write mendocs.com, how you are able to get my IP address? For example, my IP address is this. Okay, let's suppose. So how with this the network is able to figure out this? Okay, so you have a database of domain names. Okay, they are managed centrally by or some organization. Okay, let me get the name of the organization. Okay, it's ICANN, I guess. Okay,
I can.
yeah, so it will be ICANN. So this organization is responsible for maintaining a mapping between the domain name and the IP address. It has various databases through which it provides this information. So first thing that this does is domain lookup. It goes on the DBs where it finds the map for IP address, and then it is able to communicate with it. Okay, so this is IP address. In place of this you can also write this. Okay, it will still work. Now this is a port. What is a port? So port in software is a software construct. Suppose this is your OS. OS allows outer world to communicate with it. Okay, and this software constructs are called port. For example, port 80, it can be port 5000, it can be port any port. Okay, so there is a process, there is a program which is listening to this port. Basically OS allows outer world to communicate with its system, and there is a program which receives the information which is supplied to a port. Okay, so by default port 80 is the place where all the request goes when you make the HTTP request. When you make HTTPS request, by default it goes to a port 443. Okay, so suppose I have a service at 8080, you want to access that, you will have to specify it here. Okay, so this is what port is. So I think we have covered a lot of things today, and this was very exciting thing for me when I learned about this. I hope you must have also enjoyed this.